All right, welcome to today's class. This is Sigma Tech Consult Limited. Today we will have to take a topic in mathematics, algebra, part 2. In our last class, we did some part of algebra. Today we'll take the other part of algebraic expressions. Okay. Today we're going to look at the LCM, knowing how to find the LCM of algebraic expressions, and of course, knowing how to solve problems on algebraic fractions. Okay, so our learning objectives today is by the end of the lessons, you should be able to find the LCM of algebraic expressions, and of course, add and subtract algebraic fractions. Okay, add and subtract algebraic fraction, multiply algebraic fraction, divide algebraic fractions. Those are the things we will learn today. In our last class, we defined what algebra is, which I believe you can recall. Algebra is a mathematical expression whereby letters, symbols, or all that, okay, represent a quantity or a number. Okay, so is that particular part of mathematics that has to do with the use of letters and symbols. All right, so today we are going to look at the lowest common multiples of algebraic expressions. So we have some examples here. I will just take like one or two examples here, then we'll go to the app and get some examples from the past questions that we have there. Okay, so we have the first one there, the first example. I want to believe that by now you know what LCM is. LCM is lowest common multiple. Okay, so it is the multiple of some numbers that you will be asked to find. Okay, all right, so they are asking us to find the LCM of 8a and 6a. Now, the difference is that when we did the HCF of algebraic expressions, we had to use the method of division. Okay, here we'll just use the method of division, which is the simplest method of solving LCMs. Okay, just like you have your normal LCM of numbers, of real numbers, like they would have given you just 8 and 6, and they ask you to find the LCM. The same way, the same process, the same method you can apply in solving LCM of algebraic expressions. So the same way you bring your two numbers, you have 8. If I were you, bring the first one, 6a and 8a. Okay. Remember, in LCM, our goal is to make sure that these numbers are divided to a point where they become 1. So we keep dividing each of the quantity by their factors. Okay, until that factor becomes 1, which no matter what we divide with 1, because 1 will be a factor of that 1, it will keep giving us 1. So it is when we terminate at 1 that we get our answer. So the first thing we have here is 6a and 8a. Okay, 6a. If I were you, we can start with a, or you can start with the factor of 6, factor of 8, and all that. So let's start with factor of 6. 6 and 8 have common factors. 2 is a common factor. If you apply 2 here, 2 into 6 is 3. So this is 3a. 2 into 8a will give us 4a. Okay. Now we have 3a, we have 4a. Now, if we are doing fraction HCF, you know, at this point 3 and 4 don't have common factor. So The only common factor they have here is a and a, so we'll just do a, and this will give us 3 and 4. But for LCM, we must make sure, even if it's the factor of that number that is itself, we'll use it to divide that number until it gets to 1. Okay, so here 2 is still a factor of 4. Even though 2 is not a factor of 3, 2 is still a factor of 4. Do you understand? So we will also use 2. 2 into 3a cannot go because 2 is not a factor of 3. So this still comes down, we'll still bring it down as 3a. Then 2 into 4a will give us 2a. 2 is still a factor here of itself. Remember, the goal is to make sure that everything comes down to 1. All right, so 2 here into 3, it won't go, so we'll just bring it down. 2 into 2 is 1. That is 1 times a is a. So here now is a. Okay? So before we go into a, I want us to complete the numbers first that we have there. So what that means is 3 is the factor of 3. Okay? So 3 into 3 is 1. 1 times a. So this is now a, and this is our a. So a and a, they are factors also, because a divide a will give us 1. A divide a will give us 1. So at this point, we have gotten to a point where we have all these multiples reduced to 1. Okay, so at this point now we say therefore LCM of 6a and 8a is equal to, you multiply everything that you're given here. Okay, you multiply everything here. So this is 2 times 2 times 2 times 3 times a. Okay, so 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. 24 times a. So this is 24a. So the LCM of 6a and 8a is 24a. All right, so that is that. So we can have the next one before we go into the exam guide. So let's see the solution of this now. All right, find the LCM of 6ab and 5b squared. All right, so the same thing you do, you bring your 5 or 6, whichever one you want. Let's say 6ab here and 5b squared here. Remember, the goal is that we must divide everything to get to 1 as the final terminating number here. Okay, all right, so here if we look at 6 and 5, they don't have any common factor. 6 and 5, they don't have any common factor, but 2 is a factor of 6. I can go ahead and just say I put 6 here, 6 give me, and I put 5 here. Okay, but it is good so that when you're multiplying, if the numbers are too large for you to multiply, when you get to this point, it will be somehow difficult for you. So it's good. It's good unless when you have mastery of this, you can just go ahead and say 6 into this place is AB. You have 5b squared. Then you have 5 here. AB. This is now b squared. Okay, when you gain mastery. But for now, okay, that you are still beginning, I will advise begin with the least factors of the numbers. Okay, begin with the least factors of the numbers. So we go here. 2 into 6 is 3ab. That is 2 into 6ab is 3ab. 2 into 5b squared cannot go because 2 is not a factor of 5. So 5b squared will remain there. Okay, 2 cannot affect it. Here 3 is a factor of itself. So we go with 3. 3 into itself, 3 divided itself is 1. So 1 times AB, this is AB. So this is 5b squared. Why is it 5b squared? Because 3 can't also go into 5. Okay? So the next thing is, let's use 5 so that we can bring all the numbers down first. If you look at 5, 5 is a prime number. Okay? Only 1 and itself are its factors. So we use 5 there because we cannot use 1. If we use 1, it will keep giving us 5, 5, 5, 5, 5. 1 divided 5 is 5. So we use 5 so that it can be broken down to 1. So 5 into this will come down because it will not go. 5 into itself is 1. 1 times b square is b square. You get that? So now the next thing we have here, we have a here. Okay, so let's remove a. A into itself will now be b. So a has cancelled a. A divide a is 1. 1 times b is b. Where a into b square cannot go, so we bring the b square down. The next thing we have there is what? B. So we have b here, okay? B into itself is 1. So this is 1. B into b square. B into b square can only remove 1b. Remember, b square means b times b, okay? So what it means is that there are 2 b's here. So this b can only remove 1b so that 1b will be left, okay? So we now have, remember, we have not gotten to 1 in b part. So we still go with b. B here, we cannot go, bring the 1 down. B into b is 1, okay? At this point now, we have gotten our factors that will give us the LCM, okay? So we say, therefore, LCM of 6ab and 5b squared is equal to 2 times 3 times 5 times a times b times b. And that will give us, if we look at this, 2 times 3 is 6. 6 times 5 is 30. 30 times a is 30a. 30a times b is 30ab. 30ab times b is 30ab squared. So our LCM is 30ab what? Squared. All right. You get that? So let's look into the exam guide and get some questions there. Okay, so we will go into this exam guide. Okay, so we have some questions here on LCM. I think let's take the first question there, question number 1. They say we should find the LCM. So let's get the solution of this. So they say we should find the LCM of 9ab, 18b squared, and 3ab. So we put our numbers into a box, okay? I will advise you just begin with the list number there. So 3ab, we begin with 3ab, then we have 9ab, then we have 18b squared. So all these, we box them, okay? Yeah, so let's go. So we look at the 3 numbers or quantities given. They have common factors. 3 is a common factor here, here, and here. 3 is common here, 3 is common here, in the sense that 3 can divide 3, 3 can divide 9 without remainder, 3 can divide 18 too without remainder. Is that okay now? Okay, so we have 3. If 3 go here, 3 into itself is 1. 1 times AB, so this is now AB. So 3 into 9AB will now give us 3, because 3 into 9 will give us 3AB. You get that? Then 3 into 18 gives us 6. 3 into 18 is 6. So this is 6b squared. You get that? All right, the next thing we do, let's remove the numbers first before we enter the letters. So we have 3 and 3 here, 3 common here and here. So we use 3 again. 3 into AB can't go, so we bring the AB down. 3 into 3AB, this will now be, 3 into itself is 1. 1 times AB, this is now AB. Okay, so 3 into 6b squared will give us 2 rather. Give us 2b squared. Because 3 divided 6 will give us 2. We have AB, and 2AB. So we still have a number that needs to go out. Okay, so 2 should go and remove this 2. Okay, so this AB, because 2 into this can't go, so we'll just bring them down. Then 2 into itself is 1. Okay, 1 times b squared is b squared. So at this point now we have alphabets, okay? We have letters. So let's remove the quantity of the quantity A first. So A, we bring A in. A will remove this A so that B will be alone. A into A is 1 times B. B is now alone. Then B square still comes down. Then we have B now all through. So B into this one is 1. B into itself is 1. B into B. Remember what we did here? I said B will remove one of the B's. So this B removes 1. So 1B will be left. So B, again, we go so that it can take away this one. B, this will come down, and this will come down. So we say, therefore, LCM of 3AB, 9AB, and 18B square is equal to, you multiply all this, 3 times 3 times 2 times A times B times B. Okay? So 3 times 3 is 9. 9 times 2 is 18. 18 times A is 18A. 18A times B is 18AB. 18AB times B again is 18AB squared. So the answer is 18AB squared. And if we look at our option A is our right answer there. Okay? So we move on to the next question. Let's look at the next question. This question says, find the LCM of 9x. So let me remove this. Find the LCM of 9x and 4x squared y. So we put our 4x squared y in solution. Okay. 4x squared y. Then we have 9x. So let's see what we have here. So 2 into 4. So let's go with 2. 2 into 4 will give us 2x squared y. Then 2 into 9 will give us a remainder, so we bring the 9 down, 9x. 2 again, 2 into itself is 1. 1 times x squared is now x squared y. Okay, 2 into here again, it won't go, so 9x will still come down. What? Let's look for a way and bring 9 out. Okay, 3 is a factor of 9, so 3 comes in. 3 into this place will still give us this because it can't do anything about what is happening here. Then 3 into 9, this is 3x. Okay? Then the next thing we'll do is to remove 3 too. So bringing in 3. 3 into this place, this is x squared y. Okay? Then 3 into this 3x is 1. 3 into 3 is 1. 1 times x is x. So this is x. Okay, so remember we have quantity of x and y now, so let's use x. X into x, we remove the first x here, so 1x will still be left, so this is xy. Then x into this x is gone, so this is 1. Okay, so we still have x here, so x will still go. X into this will give us 1. X into this y, so x into x is 1. 1 times y, so this is y. Y will still be there. Then here, we'll bring down the 1 again. Okay? Then we have y, which is left here. Y into 1, into y is 1. We'll bring down this 1. Okay? So we say, therefore, LCM of 4x squared y and 9x is equal to this. Okay? 2 times 2 times 3 times 3, okay, times 3, 1, 2, 3, 4, 1, 2, 3, okay, times x, and times what? Y. So let's see what this gives us now. Okay, so 2 times 2, 2 times 2 is 4. 4 times 2 is 8. You see that? 2 times 2 is 4. 4 times 2, 4 times 3 rather is 12. Okay? 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. Do you get that now? Is what? 36. 36 times x is 36x. Okay? 36x times x is 36x squared. 36x squared times y is 36x squared y. So this is 36x squared y, which is our LCM of 4x squared y and 9x. If we look at our options, option A is the correct option. Okay? So let's see if we can get, okay, this one, there is no number. We have just letters. They ask us to find the LCM of those letters we have there. So number 5, full stop, solution. So they are asking us to find the LCM of this. Simply put them, this is x squared, then we have xy, then we have yz. Okay? All right, so let's start with the first quantity there, x. X into x is 1. Okay, x into x is 1, but there is one x left. So this x can only move this first one. So x is still left there, okay? X into itself here is 1. 1 times y, this is y. X into this place cannot, there is nothing common, okay? So this is y, z. Okay? So this is x again because we have an element of x here. X into itself is 1, so this is 1. X into y, it can't go, so we'll bring the y down, we'll bring the yz down because they can't. Okay? So we go to y. Y, this come down, y into y is 1, y into y here is 1. 1 times z is z. So the next thing we do is we bring z in. This becomes 1, this becomes 1, this becomes 1. Simple. So what that is LCM of x squared, xy, and yz is equal to x times y times z, which will give us equal to x times x is x squared times y times z. So it will give us x squared y z. X squared y z. That is option E being the correct option. So let's see if we have something more technical. Let me see if there's anything more technical for you to find. I think every other thing that we have here are things you can do. Okay? All right. Okay, we have, let's just have this one, then move to other things, okay? So let's get the solution of that. This will be a very long division. So we have 24y squared, and we have 72xy. All right? So let's look at this. So 2, let's start with our 2. We know 2 is common in 24 and 72. So 2 here. 2 in 24 will give us 12y squared. 2 in 72, 2 in 7, okay, will give us 3, remainder 1, okay? We'll put the 1 here, it becomes 12. 2 in 12 is 36, okay? So this 2 into 72, when dealing with large numbers, it's very good you do your division from the smaller number that can be divided easily by you, okay? And just take that step I just mentioned. Okay, so this is xy, okay? 2 again, 2 into 12, this is 6y squared. 2 into 36, 2 into 3 is 1, remainder what? 1. Put the 1 here is 16. 2 into 16 is 8. So this is xy. You get the point? So the next thing again, 2 is still a factor. 2 here, 2 into 6 is 3, so 3y squared. 2 into 18, of course, you know, is 9. So this is 9xy. 3 is common factors here now, right? So 3 into 3 is 1. 1 times y squared is y squared. Then 3 into 9 is 3xy. 3 is also a factor here. So 3 into this place will still come down and become this. Then this becomes 3 into 3 is 1 times this. This is x, y. What is the next thing we'll do now? Y. Or let's do x. X, y squared comes down, okay? Then we have x into x is 1. 1 times y is y. So y, we deal with y now. Y here, we only remove this one, just like I said. Then this y will come down. Y into y is 1. So this is 1. Okay? Then y comes here. Y into this is this. So we say, therefore, LCM of 24 y squared and 72 xy is equal to multiplication of all these, okay? So this is 2 times 2 times 2, 1, 2, 3. So times 3 times 3 times 1, 2, 3, 1, 2 times x times y times y. So let's see what that is now. So 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. 24 times 3 is 72. Okay? Now, 72, how did I get that? 24 times 3, right? 3 times 4 is 12. 12, you carry 1 up here. 3 times 2 is what? 6 plus 1, 7. So that's 72. So all this 72 times x is 72x. Okay? This times, I think this 1, 2, 3, 1, 2, 3 times 3. Okay? So times x times y times y. Sorry about that. So this 72 at this point. 72 times x is 72x times y, 72xy. Okay, times y again, 72xy squared. So this is 72xy squared. So that is our answer. So the correct option there is option B. All right? Okay, so that is our correct option. So let's look at addition and subtractions of algebraic fractions. So let's look at additions and subtractions of algebraic fractions. Okay, just like we have normal fractions, we also have fractions that can be presented to us in algebraic form. So we want to look at how to solve those fractions. Okay, I'll just call it operations. Operations with what? Algebraic what? Fractions. By operation, I mean the addition, subtraction, multiplication, and all that. Okay? All right. So let's see an example. This says number 1. Okay? So we say we should simplify this. This is a fraction, but it is a fraction that has an algebraic expression in it. Okay? So simple. The same way we solve fraction. Okay? 5a, bring your question down or your expression down, minus 3 what? A over 8a. So in fraction, the denominator of these two expressions or these two fractions, you rule a line, bring the denominator down. Since the denominators are the same, there is no point looking for the LCM because the LCM of 8 and 8 is still 8. Okay? So you just bring 8 down. All right, 8, this 8 divides this 8 is 1. 1, the answer times its numerator. So 1 times 3a gives us what? 3a. So you bring down the minus, okay? So this 8 divided 8 is 1 times 5a. This is also 5 what? A, all right? Okay, so 5a minus 3a, 5a minus 3a gives us 2a all over what? 8. All right? 2a all over 8, 2 and 8 are
common. Okay, there is a common factor between them. 2 here is 1. 2 into 8 is 4. So at the end of the day, our answer is A all over what? 4. So that is the answer. So if they ask you to solve 5A over 8 and this, the answer is A all over 4. Okay, let's see another expression, or let's see another example where the denominator is the one carrying the algebraic expression. This first one we did, the numerator is the one carrying the algebraic expression. Let's see a situation where the denominator carries the algebraic expression. So let's see, they have two different quantities here, okay, with different variables. Okay, so this will be a bit technical, but it's easy to solve. So let's look at the solution. Solution to this will be 2 over 5x plus 1 over 3y. Now look up. Remember, in solving fractions, when you want to solve fractions whose denominators are different, what you do is you look for what? The LCM of the denominators. When you get the LCM of the denominators, you rule a line, then bring that LCM here, then divide that LCM by these two denominators and multiply by that. Okay, now see where the knowledge of LCM of algebraic expression comes to play now. So you can apply what we have just learned in what we want to do now. You see the point? So they gave us 3y and 5x. Okay, so it's simply to do what? To get the LCM of what? 5x and 3y. So we are doing LCM of 3y and 5x. That is what we are doing here now. So here there is no factor common to 3 and 5. So 3 goes here, this will be y, and this will be 5x. 5 goes here, this will be y, and this will be what? X, because 5 into itself is 1. So x go here, this will be y, this will be 1. Y goes here, this will be 1 and 1. So it means that its LCM is equal to 3 times 5 times x times y. So this will be 3 times 5 is 15 times x is 15x times y, 15xy. It means that here our denominator is 15xy. That is our denominator. Now, we look at this now. 3, which is the denominator of this fraction, you can start with either this or this, okay? 3 divide 15xy. The answer you get there, you multiply it by the numerator, okay? So this is 15xy, 3 will divide it. What would that be? If 15xy is divided by what? 3y. What it means is that y will cancel itself. 3 into itself is 1. 3 into 15 is 5. So it is 5x. You see that now? So it means 3y divide 15xy will give us 5x. So 5x times 1 is still 5x. So this is 5x. So this is plus. You see that? The next one now is 5x divide 15xy. So we have 15xy divided by what? 5x. So x removes this. 5 here is 1. 5 into 15 is 3. 3 times y is 3y. So we have 3y, which is our answer when we divided this by this. So 3y times 2. So this is 3y times 2. It will give us 2 times 3, which is what? 6y. So this is 6y. Okay? Now, if you look at this, because these two quantities don't have common terms, the reason why we could subtract 3a from 5 is because they have a common term, a common unknown figure or letter that is common. Okay, this is a and this is a, so they can subtract. Okay, they have something in common, they have like terms. But here, because y is different from x, this cannot be simplified more than this. It is only in multiplication that it can be simplified, but in addition and subtraction, it cannot be simplified. So this is our answer. Okay, our answer is 6y plus 5x all over 15xy. That is our answer there. You get the point now? Now, so someone will say, why don't we this x to cancel this one, this y to cancel this one? No, it is only a multiplication. If this was to be 6y times 5x all over 15xy, exactly at this point, that is when we would have done this. Okay, but for the fact that it is like this, it can be simplified more than that. So that is your answer. Okay, so let's look at the exam guide and see if we can get some questions there. Let's look at our exam guide app and let's get something in okay, let's go to algebraic processes. We'll get something there. Okay, so let's look up some questions here with okay, let's look at this. They say number 3, if P is equal to 2 all over 3t minus 1, 3t minus 1, okay, plus 1 all over 2t minus 2, 3t minus 2. Okay, they say find P when t is equal to 1. So they say find what? Find P when t is equal to what? 1. So let's look at this. Solution. So they are saying that P is equal to 2 over 3t minus 1 plus 1 over 3t minus 2. So this is actually a substitution question, okay, though it has what is it called? Algebraic fraction in it. This is an algebraic fraction, okay, but it's a substitution question. So they say we should find the value of P when t is 1. What they are asking us to do is substitute the value of t equals to 1. They say when t is equal to 1. It means anywhere you have t, substitute the value of t for what? 1. So P will be equal to 2 all over 3 into 1, because 3t means 3 times t, minus 1, then plus 1 all over 3t is 1 minus 2. Do you get that now? So that is what they're asking us to do. All right? All right. So that will mean P will be equal to 2 all over 3 times 1 is 3. Okay? 3 minus 1 is 2. Then plus 1 all over 3 times 1 is 3. 3 minus 2 is 1. Okay? So our answer is 2 divide 2 is 1. 1 divide 1 is 1. So P, say therefore P is equal to what? 2. That is actually what they want us to do. So the correct option there is E. Okay, but I'm looking for some other questions that we have this in the. All right, let's solve this. They say solve R all over 2 is equal to 1 over 2 plus this. So let's see what that is. This is very good. So we can apply this operation here. So solution. So we have, okay, we have R over 2 is equal to 1 over 2 plus 2R over 5. Okay, here, okay, let's simplify this place. Okay, so what it will mean is that LCM of 2 and 5, we'll bring it down here. LCM of 2 and 5 is 10, even without solving. Okay, if you see 2, especially for 2, what is it called? 2 numbers that don't have common factors, or 2 prime numbers. Okay, if they ask you to look for the LCM, just multiply the 2 numbers. That is the LCM. So the LCM of 2 and 5 is 2 times 5, that is 10. LCM of 3 and 5 is 3 times 5, that is 15, just like that. LCM of 7 and 5 is 7 times 5, that is 35. So just that, okay? All right, so LCM of 2 and 5 is 10. How? 2, 5, okay? 2 here is 1, this is 5. 5, 1, 1. 2 times 5 is equal to 10, okay? So that is how I got that. So we do this. 5 divided 10 is 2, right? 2 times 2, that's 2 times 2r is what? 4r. Are you with me now? 5 into 10 is 2. 2 times 2r is 4r. So plus 10 divided by this 2 is 5. 5 times 1 is 5. Okay? So these are, we bring our equal to down, remember? All right. So we have gotten this fraction we have here now is one single fraction. Here it was 2 fractions. There are some examiners or some questions that they will ask you to make these 2 things one fraction. At this point, this is 1 fraction. Okay. Now, what we do next now is to cross multiply. We only cross multiply in mathematics when we have 1 fraction each in this part of the equation and this other part of the equation. So since we have arrived to the point where we have just 1 fraction here and 1 fraction here, we can do what? Cross multiply. Okay, so what that means is 10 should come and multiply here, 2 should go and multiply here, or R should go, whichever one. If you want to go this way, you can go this way, you can go. I choose to go 10 should go to R. So this will mean 10 times R, that is R times 10 is equal to 2 times 5, that is 2 times 5 plus 4R. You get that? So this will be 10 times R is 10R is equal to 2 times 5 is 10 plus 2 times 4R is 8R. Okay? So at this point, we have terms that are alike. Okay? Should go to one side. We have 8R here, we have 10R here. So 8R should go and meet. Okay? The process is called collection of like terms. Okay? So we collect like terms. Collect like terms. Okay? So what that means is 10R, 8 is carrying plus sign at the back of it. So once it crosses, I call this in a bridge. Once it crosses this bridge, it must sacrifice what it is carrying for another thing. So there is an exchange that must happen here. The plus sign that 8 has will be exchanged by a minus sign. Okay? So it doesn't just cross like that. Once you want to cross, you must drop something in exchange for something. So 8 comes here. This will now become 8R is equal to 10 will not be alone in this other side of the equation. 10R minus 8R will give us 2R is equal to 10. We divide both sides by the coefficient of R. The coefficient of R is 2. I've told you before, coefficient of any particular unknown is that number, is that quantity that is multiplying, okay, the unknown, or simply said in a layman's way, that number that is at the back of an unknown. 2 is at the back of this unknown. So that is the coefficient. Okay? All right. So this is, we divide by 2 and we divide by 2. 2 into here is 1. 1 times R is R. So R, 2 here is 1. 2 into 10 is 5. So R is equals to 5. So if we check that, our correct option there is option A. All right? Okay. I think for that, for algebra, everything you need to know about algebra, you have known them, and at that point, I want to believe questions that come from this, you can easily solve them. Thank you so much.